Hello, good morning, everybody, and welcome to our Mathematics 9 class. Today, we are going to talk about trigonometric ratios of special angles. In lesson 1, we have talked about the 6 trigonometric ratios. Can you recite them with me? We have sine, cosine, tangent, cosecant, secant, and cotangent. In lesson 2, we have learned how to solve for these trigonometric ratios using a scientific calculator. But don't you know that there are special angles in a right triangle? And these special angles, once you will find for their trigonometric ratios, the 6 functions, you don't need a calculator because you can simply remember, or you can also memorize them. Let's start by reciting today's memory verse. And it's found in Psalm 16, verse 8. It says, I have set the Lord continually before me, because he is at my right hand. I will not be shaken. Your MVCA boosters today is about the perfect love triangle. You see this photo? This is the photo of a perfect love triangle. It's having you and others in a horizontal relationship. Everything is equal and you will be fair in all of your dealings. You love each other with all our hearts, soul, and mind. And all of us, we are into a relationship with the Lord. In what instances or situations can the perfect love triangle be broken? You need to list 2. At the end of today's class, you'll be able to find the trigonometric ratios of special angles. And here's our venture. Actually, I skipped the venture activity because you need to measure that with your protector. So let's continue with the chat with the expert. Now, in the previous lessons, we have talked about special right triangles. There are 3 special acute angles. These are 30 degrees, 45 degrees, and 60 degrees. And we have 2 special right triangles. The first special right triangle is the isosceles right triangle, where the legs are equal. Now let's remember the 45-45-90 triangle theorem. It states that if the length of the leg is x, the other leg will also measure x, and the hypotenuse will measure square root of 2 of the leg x. What if the hypotenuse is given? For example, here, the hypotenuse is given x, and these legs are equal. How do we find the legs? Each leg measures square root of 2 over 2 of your hypotenuse. So again, if the leg is given, the hypotenuse is square root of 2 of the leg. But if the hypotenuse is given, the leg is square root of 2 over 2 of the hypotenuse. The next special right triangle is what we call the 30-60-90 triangle. It means that its angles are 30 degrees, 60 degrees, and 90. What's the theorem all about? Given that the opposite side of 30 degrees, the shorter leg is x, the hypotenuse is twice of the shorter leg, that's 2x, and the longer leg is square root of 3 of the shorter leg, square root of 3 of x. So for example, let's have 30 degrees, 60, and this one measures 7. So if the opposite of 30 measures 7 units, the hypotenuse is double, 14, while the opposite of 60 is 7 square root of 3. Let's go to the next one. We will find the missing side measurements of these special right triangles. Let's start. This is an isosceles right triangle because this measures 45 degrees. So the other will also measure 45 degrees. Now, since the one leg measures 3 square root of 2, then the other leg will also measure 3 square root of 2. Now, what's the measure of the hypotenuse? Remember, it is square root of 2 of the leg. Then we will multiply it. We have 3 and the radical, 2 times 2, 4. The square root of 2 of 4 is 2. So we have 3 times 2. Thus, our hypotenuse measures 6. We say that the measure of x is 6, while the measure of y is 3 square root of 2. Let's go to the next one. Here, we will solve for the side of the missing angle measurements. So we see this is a 30, 60, 90 triangle. And the given is the opposite of, what's this one? The opposite of 60, 9. Now, if the given is the opposite of 60, then we can start working with the small angle, the opposite of the small angle, which is T. Remember that the short, let me first write here, the longer leg is equal to square root of 3 of the shorter leg. And the longer leg here is 9, it's given. From square root of 3 of the shorter. We divide both sides by square root of 3. So the shorter side is equal to 9 over square root of 3. But we need to rationalize our denominator. So we'll multiply that by square root of 3 over square root of 3. So we have 9 times square root of 3 over square root of 9, because that's 3 times 3. Square root of 9 is equal to 3. So 9 square root of 3 over 3, that becomes 3 square root of 3. And remember, the opposite of the right angle, the hypotenuse, is twice of the shorter angle. So you have twice of 3 times square root of 3. We have 2 times 3, 6 square root of 3. So our S is 6 square root of 3, while our T is 3 square root of 3. Let's go to the next example. Now, you check, is it an isosceles or a 30, 60, 90? The given is a 60, so this is a 30-degree angle. The given side measurement is the hypotenuse. And remember, the hypotenuse is twice as long as a shorter side. So if your hypotenuse is 16, then the opposite of 30 is 8. How about the longer side? It's the shorter side times square root of 3. So 8 square root of 3. Let's go to the next one, the next exercise. In this exercise, we will compare the trigonometric ratios of two isosceles right triangles. If you see, the one on the left is an isosceles right triangle. Its opposite, example, the opposite of 45 is 4. The adjacent is also 4, while the hypotenuse is 4 square root of 2. In the other triangle, still 45. So the opposite is 7. The adjacent is 7, while the hypotenuse is 7 square root of 2. Let's check for their trigonometric ratios. We'll start with the first triangle, sine 45. That will be opposite over hypotenuse. That is 4 over 4 square root of 2. We'll rationalize it. Multiply by square root of 2 over square root of 2. Cancel the 4. So we'll have square root of 2 over, they are the same. So we can cancel, it's 2. This is our sine 45. Next, cosine 45. Adjacent over hypotenuse. The same, right? 4 over 4 square root of 2. They are the same with the first one, so it will end up with the same answer. Square root of 2 over 2. Next, tangent 45. TOA. So we have 4 over 4. The answer is 1. How about the cosecant? The cosecant 45 is the opposite of sine 45, the inverse. So you have 2 over square root of 2. Rationalize it. Multiply both by square root of 2. We'll have 2 square root of 2 over, this one is 2. Cancel. You have square root of 2. The second 45 is the same, right? So we have square root of 2. While the cotangent 45 is the inverse of 1. We still have 1. So these are now our answers. Now let's go to the other one. Let's start with sine 45. But they have different side measures. So that's 7 over 7 square root of 2. Cancel that. Rationalize. The answer is square root of 2 over 2. Cosine 45 is the same. While tangent 45 is TOA. 7 over 7 is 1. You check. In one triangle, the sine is square root of 2 over 2. In this triangle, the sine is still square root of 2 over 2. The same with the cosine, and their tangents are the same. So it means that no matter what the side measurement is, as long as we are looking at the same reference angle, 45 degrees, then they will have the same trigonometric ratios. With that one, let me give you the table for the trigonometric functions for 45 degrees. Sine 45 is square root of 2 over 2. The same with cosine 45. Tangent 45 is 1. Cosecant 45 and secant 45 degrees are both square root of 2. And our cotangent 45 is 1. Let's go to the 30-degree angle. Again, our reference angle this time is 30 degrees. So with the first triangle, our opposite is 5, this one. Our adjacent is 5 squared of 3. And our hypotenuse is 10. In the other triangle, still at 30 degrees, our opposite is 3. Our adjacent is 3 squared of 3. Our hypotenuse is 6. Let's start. Sine 30. That's so 5 over 10, it's 1/2. Next, cosine 30. That's ka. 5 squared of 3 over 10. It's 1 and 2. So you have square root of 3 over 2. Next, tangent 30. That's towa, O over A. Our opposite is 5. Our adjacent is 5 square root of 3. We cancel 5, but we need to rationalize square root of 3. So multiply the numerator and the denominator by square root of 3. Square root of 3 over square root of 9, because that's 3 times 3, and square root of 9 is equal to 3. So our tangent 30 is square root 3 over 3. How about our cosecant? Our cosecant 30 is the inverse. That's 2. Our secant 30 is the inverse of the cosine. That's 2 over square root of 3. Rationalize. So you have 2 square root of 3 over multiply square root of 9. You have 2 square root of 3 over 3. How about our cotangent? The opposite, that's sokatowa choshakao. So 5 square root of 3 over 5, cancel. We're left with square root of 3. Let's check with the other triangle if they have the same. Sine 30. So 3 over 6, that's 1/2. They are just the same, right? Next, cosine 30. Ka. We have 3 square root of 3 over 6. That's square root of 3 over 2. The same. And the rest will be the same. So again, no matter what the side measurement is, as long as your reference angle is 30 degrees, they will end up with the same trigonometric functions. And here's a trigonometric functions for 30 degrees. Sine 30 is 1/2. Cosine 30 is square root of 3 over 2. Tangent 30 is square root of 3 over 3. Cosecant 30 is 2. Secant 30 is 2 square root of 3 over 3. And cotangent 30 is square root of 3. Let's go to the last example. You have the same triangles, but this time our reference angle will be at 60. So here, 60. The opposite side of 60 is 5 square root of 3. The adjacent side is 5, while the hypotenuse is 10. In the other triangle, reference angle is 60. Here's the opposite. The opposite is 3 square root of 3. The adjacent is 3, while the hypotenuse is 6. Let's start with sine 60. So 5 square root of 3 over 10. So that will be square root of 3 over 2. Next, cosine. We have ka, 5 over 10, 1/2. Tangent, we have TOWA. 5 square root of 3 over the adjacent 5. Cancel them. That's square root of 3. Next, cosecant 60. CHO. We have 10 over 5 square root of 3. That's 2 and 1. Rationalize. We have 2 square root of 3 over 3. Next, secant. The inverse, SHA. 10 over 5, that's 2. And the cotangent, COW. You have 5 over 5 square root of 3. Cancel. Rationalize. So square root of 3 over 3. Let's check the other triangle. Sine 60. So 3 square root of 3 over 6. That's square root of 3 over 2. Next, cosine. Ka. 3 over 6, that is 1/2. If you see, no matter what the side measurement is, as long as we have the same reference angle 60, we'll end up with the same answer. So here is the trigonometric function for 60 degrees. Sine 60 is square root of 3 over 2. Cosine 60 is 1/2. Tangent 60 is square root of 3. Cosecant 60 is 2 square root of 3 over 3. Secant 60 is 2. And cotangent 60 is square root of 3 over 3. And here's the summary of all of these angles. 30, 45, and 60. And these are the trigonometric functions. You can keep this page so that you will have a guide as you solve trigonometric functions of special angles. If you have questions, feel free to message me in Telegram. Thank you for joining. Bye-bye.